Hello everyone and welcome back to the channel. I am Sahil Sawant and in this lecture, let's understand one of the most conceptual topics for JEE Physics, that is damped and forced oscillations. If you think oscillations always continue forever, the real life is going to say no. That is where dampening and resonance come in. In real systems, energy is always lost due to friction, air resistance or internal losses. When an oscillating system gradually loses the energy and its amplitude decreases with time, we call it a damped oscillation. The motion still remains oscillatory, but the amplitude keeps on shrinking little by little. This decrease in amplitude is controlled by something we call a dampening factor. Higher the dampening factor means faster the loss of energy. In exam, the students have to remember dampening does not change frequency much for lighting dampening, but it reduces amplitude exponentially. There are three important cases under undamped oscillations. System oscillates with decreasing amplitude. Critical damped oscillations, in which system returns to the equilibrium in minimum time without oscillation. And overdamped oscillations. System returns slowly with no oscillations. Car shock absorbers are designed to be critically damped. Now comes the interesting part, that is the forced oscillations. Here, an external periodic force is continuously applied to the system. Even if dampening is present, the system keeps oscillating because of the energy being supplied from outside. The steady state motion depends only on the driving force and not on the initial conditions. Resonance occurs when the frequency of external forces matches the natural frequency of the system. At resonance, amplitude becomes minimum. In real systems with dampening, resonance frequency is slightly less than the natural frequency. This concept is extremely important from the numericals point of view. The exams usually test resonance curves, bandwidth, energy losses, and reasoning based questions. The one mistake students usually make is to ignore dampening while applying resonance conditions. Now here is a question for you. Solve it and comment your answers below. If this reel has helped you, like the video and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full length explanations.